my dear children and respected teachers. A warm welcome to Physical Science online bridge course classes. My dear children, today we are going to explore some important topics of atoms and atomic theories. Are you ready? Dear children, can you identify these objects? Ice, chalk, marbles, water, ink, water vapor, incense stick fumes. Do you know, my dear children, in chemistry we call every object as matter or substance. How do we define matter? Look here, my dear children. This matter has some mass. We can see the readings in the weighing machine. Here this matter occupies some space. So the matter can be defined as follows. Anything that has some mass and occupies some space is defined as the matter. If you observe these matters, we can find that they are looking different from each other. Isn't it, my dear children? The appearance of a matter is its physical state. The matter is available in three physical states. They are number 1, solid state, number 2, liquid state, number 3, gaseous state. My dear children, now let us try to understand the properties of matter. Number 1, shape, number 2, volume, number 3, compressibility, number 4, diffusion. Let us discuss about one by one. Number 1, shape. Look here, my dear children, these are marbles. These marbles have a fixed shape. The shape of these marbles is not changing. Now we can confirm that solids have fixed shape. My dear children, let us take some water in a beaker. Now tell me, children, what is the shape of the water? The shape of the water is nothing but the shape of the beaker. Now exchange this water into a conical flask. Now tell me the shape of the water, my dear children. Yes, very good. The shape of the water is the shape of the conical flask. That means the same water has different shapes depending on the vessels. So we can confirm that liquids do not have fixed shape. Now let us observe the fumes of the incense stick. Is the shape of the fume fixed, my dear children? No, the shape of the fumes is changing. So we can confirm that gas doesn't have a fixed shape. Now let us observe the volume, my dear children. These marbles are occupying some volume, isn't it, my dear children? The volume occupied by the marbles is not changing. So we can confirm that the volume of solids is fixed. My dear children, let us take 100 ml of water in a beaker. The volume of the water inside the beaker is 100 ml. Now exchange this water into a conical flask. How much water is there in conical flask, my dear children? The volume of the water is 100 ml only. My dear children, we can confirm that the liquids have fixed volume. My dear children, let us collect the incense stick fumes in a conical flask. Are you observing, my dear children? The fumes are spreading inside the conical flask. What is the volume of the fumes now, my dear children? Very good. The volume of the fumes is equal to the volume of the conical flask. My dear children, now slowly remove the cork. What do you observe, my dear children? The fumes are moving out of the conical flask. That means the volume of the fumes is changing. So we can confirm that gases do not have a fixed volume. Now let us discuss about compressibility. What is this, my dear children? Yes, this is a syringe. Pull the piston of the syringe out and take some rice inside the syringe. Then try to push the piston inside. Is the piston moving? No. That means solids do not have compressibility. Now suck some water into the syringe by pulling the piston back. Then close the nozzle of the syringe and press the piston inside the syringe. What do you observe, my dear children? The piston is moving hardly. That means the liquids have moderate compressibility. Now suck air into the syringe by pulling the piston back. Now there is air inside the syringe. Close the nozzle of the syringe and push the piston into the syringe. Now you can observe that the piston is moving into the syringe. That means we can confirm that the gases have high compressibility. Now let us learn about diffusion. My dear children, what is diffusion? Diffusion means spreading of a material into the space. My dear children, these are potassium dichromate crystals. Take few crystals of potassium dichromate and add these crystals to the water taken in a beaker. And observe carefully. The potassium dichromate is diffusing into the water slowly. Are you observing, my dear children? That means we can confirm that the diffusion of solid is very low. Now take few drops of ink and add it to the water taken in the beaker with the help of a dropper. What do you observe, my dear children? The ink is diffusing into the water faster than that of the potassium dichromate crystals. From this activity, we can confirm that liquids have moderate diffusion. Now observe the diffusion of gases. Observe, my dear children, how the fumes are diffusing into the atmosphere. They are diffusing very fastly. That means gases have high diffusion. My dear children, how the particles are arranged in different physical states of matter? The particles in the solids are closely arranged. The particles in the liquids are separated by moderate distances. The particles in the gases are separated by large distances. Important terms related to matter. Pure matter. If the composition of the substance doesn't change, no matter which part of the substance we are taking for examination, then the substance is called as pure matter. Examples: gold, iron, carbon dioxide, water, etc. My dear children, if you take some water in a beaker, wherever you consider the sample of water, the properties of the water do not change. So water is pure matter. Mixture. A mixture is generally made of two or more components that are not chemically combined. For example, air, fruit juice, salt water, etc. Element. When the particles of a substance contain only one type of atoms, that substance is called an element. In element, smallest particle may be atom or molecule. Look here, my dear children, this is the element. Here, same type of atoms are gathered together. So this is called an element. Compound. If atoms of different elements join together, they form a new substance known as a compound. Look here, my dear children, these are hydrogen elements. The atoms of hydrogen elements are same. This is oxygen element. The atoms in oxygen element is also same. But when these combine together, it forms a new substance called compound. My dear children, how do we understand about the nature of matter? Is there any theory regarding this? Yes. In the year 1808, the English school teacher John Dalton proposed the basic theory about the nature of matter. Let us try to understand the Dalton theory. Postulates of Dalton theory. Number 1. Matter consists of indivisible particles called atoms. Look here, my dear children, this is matter and these are the atoms. These atoms cannot be divided into parts. Number 2. Atoms are neither created nor destroyed in a chemical reaction. Reorganization of atoms occurs in chemical reactions. Look here, my dear children, these are hydrogen elements. Each hydrogen element has 7 atoms. So there are 14 hydrogen atoms. This is oxygen. There are 7 oxygen atoms. When these combine together to form water molecule, the total atoms present in the water is 21. That means no atom is destroyed and no atom is created here. Number 3. All the atoms of same elements have identical mass and identical chemical properties. Atoms of different elements have different masses and different chemical properties. Look here, my dear children, these two are hydrogen elements and atoms of these two hydrogen elements are same. Look here, this is hydrogen element, this is oxygen element. The atoms in the hydrogen element and oxygen element are not identical. Number 4. Compounds are formed when atoms of different elements combine in simple whole number ratios. That is, chemical change is the union or separation of atoms as in whole numbers. Observe, my dear children, here 2 hydrogens and 1 oxygen combine together to form water. Water is formed when two hydrogen atoms combine with one oxygen atom. Number 5. When atoms of different elements combine in different whole number of ratios, they form different compounds. Observe carefully, my dear children. If carbon and oxygen atoms are combined in 1:1 ratio, the compound formed is carbon monoxide. Whereas, if carbon and oxygen atoms are combined in 1:2 ratio, the compound formed is carbon dioxide. According to Dalton's atomic theory, the smallest particle is atom only. The atom cannot be divided further. But later, scientists proved that atom is not indivisible. It is divisible. There are some other particles inside the atom. These particles in the atom are called as subatomic particles. Look here, my dear children. These are the subatomic particles of matter. The main subatomic particles are electron, proton, and neutron. Look here, my dear children. The charge of electron is negative. The charge of proton is positive. The charge of neutron is no charge. Electron is represented with E minus, proton is represented with P plus, neutron is represented with N0. Electron is invented by J.J. Thomson, proton invented by Rutherford, neutron invented by Chadwick. My dear children, how do these subatomic particles are arranged inside the atom? Let us try to learn. The arrangement of subatomic particles in the atom is known as the structure of an atom. There are many scientists proposed their own structure of atom. The first scientist ever to propose the atomic structure is J.J. Thomson. J.J. Thomson atomic model or plum pudding model. This atomic model was proposed by J.J. Thomson in 1898. According to this model, an atom is considered to be a sphere of uniform positive charge and electrons are embedded in it. Are you observing, my dear children? Here the negative charges or electrons are embedded in the uniform positive charge inside the atom. This model was commonly called the plum pudding model, referring to the way the fruit pieces are distributed throughout a plum pudding. Number 2. The total mass of the atom is considered to be uniformly distributed throughout the atom. That means the mass of the atom is uniformly distributed in the atom. Number 3. The negative and the positive charges are supposed to balance out and the atom as a whole is electrically neutral. Which means, my dear children, the number of positive charges and negative charges in the atom are same. One of J.J. Thomson's students, Ernest Rutherford, carried alpha particle scattering experiment through gold foil in the year 1909. Look here, my dear children. Here we can see the experimental setup done by Rutherford. Here alpha particles are generated by a source. And these alpha particles are allowed to pass through a gold foil. And the observations are recorded on the fluorescent screen. Alpha particle is having 2 units of positive charge and 4 units of mass. Look here, my dear children. Most of the alpha particles are deviated from their original path and hit the screen at different points. The deviation of alpha particles from their original path is known as scattering. Very less number of alpha particles have reverted back in the same path. Look here, my dear children. The results of this experiment are not in favor of Thomson's atomic model. Hence, Rutherford proposed a new theory to understand the structure of atom. Rutherford atomic model or planetary model. Number 1. All the positively charged particles in an atom formed a small dense center called the nucleus of the atom. The electrons were not a part of nucleus. Look here, my dear children. This is the atom and the positive charge is concentrated at the center. This is called nucleus. Number 2. Negatively charged electrons revolve around the nucleus in well-defined orbits like the planets revolve around the sun. Hence, this model is also known as planetary model. Are you observing, my dear children? Electron is revolving around the nucleus. Number 3. The size of the nucleus is very small as compared to the size of the atom. Hence, most of the atom is empty. Are you observing, my dear children? The atom size is very big and the nucleus size is very small. Rutherford's atomic structure has a conflict with the electrodynamics of the charged particles. Hence, this structure has some limitations. Rutherford atomic model limitations. An accelerated charged particle moving in a circular path would always radiate energy continuously. Thus, the revolving electron would lose energy continuously and get directed towards the positively charged nucleus and eventually crash into the nucleus. Look here, my dear children. When the electron revolves around the nucleus, it radiates energy and slowly moving towards the nucleus and finally crash into the nucleus. If this is true, the atoms would become highly unstable and the matter would not exist in the form that we see it now. Are you observing, my dear children? In order to overcome the limitations of Rutherford's model, in 1913, Niels Bohr put forward a thought that electrons can be found only in certain energy levels or regions around the nucleus. This is the nucleus, and around the nucleus there are energy levels. The energy level away from the nucleus is higher energy level, and the energy level near to the nucleus is lower energy level. Electrons must gain energy to move to a higher energy level from the lower energy level. Look here, my dear children. Electrons must lose energy to move to a lower energy level from the higher energy level. Observe, my dear children, when the electron is moving from higher energy level to lower energy level, the electron emits the energy. The electrons revolve around the nucleus in certain discrete circular orbits of the atom. These orbits or shells are called energy levels. Observe carefully. These are the energy levels where the electrons are revolving around the nucleus. While revolving in these discrete orbits, the electrons do not radiate energy, and this is the reason why electrons do not fall into the nucleus. The electron orbits or shells are represented by the letters K, L, M, N, or the numbers n is equal to 1, 2, 3, 4, so on. My dear children, in Bohr's atomic model also there are certain limitations. Bohr atomic model limitations. Niels Bohr could successfully explain the properties of hydrogen atom like the atomic spectra emitted by hydrogen atom employing this model. But this model could not predict the spectra of atoms or ions with more than one electron. Evaluation. Question number 1. Explain the different properties of matter. Question number 2. How can you say that Rutherford's atomic model is not correct? Question number 3. What are the postulates of Dalton's theory? Today we have learnt about the properties of matter, states of matter, Dalton's atomic theory, and the atomic structures proposed by different scientists in an effective manner. Hope you all understood well. That's all for today, my dear children. We will meet in the next video lesson with another beautiful topic. Bye bye. See you.